Hello everybody and welcome to the webinar. My name is Neil Cook and today's webinar is going to be focusing on designing linkages in Onshape. Those are my contact details there on the screen, so if after the webinar, if you want to ask any questions, please you can use any of those mediums there. The one at the bottom there is is my forum handle. If you've got technical questions, the forum is the best place to ask them. Go to the forum, ask a generic question, and you'll have a ton of people falling over themselves to answer it for you. And I do visit the forums virtually every day, so I can also help too. Now, I was recently working on a project which required me to design some linkages, and I just thought it'd be a good idea to share how I do that in Onshape. So first of all, as we go through the presentation, I would encourage anybody to ask questions as we go along. You can do that using the GoToWebinar questions panel and just type in your question and I will try to stop as I go along to answer them, or I'll answer them at the end. And like I mentioned already, if there's any other questions that you think of after this webinar, then you can contact me through my email or through the forum or whichever. Okay, so I'm going to start off basically just one slide to this presentation, and then we're just going to jump straight into Onshape for the remainder. And I'm going to start off with a simple technique of how to build a linkage. Now, this is from a patent from 1970. There's the images here of what it looks like on the left, and a text description of how to actually construct that manually. So I'll look at how we can actually construct that in Onshape. And really, this technique can be used in any parametric CAD system, so it doesn't have to be Onshape. But then I will look at how you apply this a similar technique using the managed in-context design capabilities of Onshape. So that's a unique capability we have, and we'll see how it works together using that capability there. Okay, and then at the end we'll take a look at how we can build some cams. Someone's saying there that the sound's not very good. Hopefully, it's rectified itself. Anyway, let's proceed. Okay, so to build this mechanism in Onshape, so here is the mechanism. Now, the idea behind this very simple mechanism is that you can actually move it backwards and forwards like this, which doesn't look anything fancy. But if I just line it up with the bottom of the Onshape screen there, just as a reference, the idea is that it draws a straight line. Okay, so it's a moving motion there, but it draws a straight line. So it's a straight line mechanism, and we'll see how we build that from scratch and the techniques we can use to actually work out what these linkage lengths are and also the pivot point positions. Okay, so to do this, what we do is create a brand new part studio, and on this front plane here, create a new sketch. Now, I find the easiest way to do these sort of things is to sketch out what the final positions of the linkage where you want it to be, and then build other sketches on top of that to actually work out the link locations and positions. So in this particular example, we're going to draw the main pivots, and I've lined it up there with the origin. And I'm also going to line the top of it with the origin, and I'll just pop it down the other side. So that's the two extents of the linkage, the left position and the right position. But really, that isn't enough information. So I can do as many as I want, but probably 3 is a good example. And what I mean by that is that you would add the link length in for the position in the middle. Because obviously, if you just go from one point to the other, the natural shape is going to be an arc. But if we specify the middle location as being vertical with horizontally constrained to the origin, then it gives us 3 positions to actually control that shape. Now, what I'm going to be doing a lot during these sketch creations is using the equal constraint, because obviously I am representing here the same linkage, so therefore they should all be the same length. So I'm going to select all these 3 guys here and use the equal constraint, or I'm going to be using E on the keyboard just to make things a little bit simpler. Okay, and if you want to, it doesn't really matter, but I'll do it for this instance. I'm going to give that a specific length and also either a position, a distance, or an angle between those. And I just want to make sure that it's a kind of fully constrained sketch. I mean, it doesn't really matter if you leave it unconstrained. It gives you perhaps a little bit more flexibility later as you're trying to iterate the linkage to get it exactly how you want it. But essentially, those are the three positions that make up my first shape. Okay, it sounds like there's a few issues with the audio here. I do apologize. I'm hoping it's recording okay. So if you're having problems with the audio, we'll try and get back to the recording later. Okay, so that is my first shape. I'll turn the planes off. Now I'm going to create another sketch, and this sketch is going to represent the linkages, or how we're going to work out the linkages. So we know from our initial idea, or perhaps a napkin sketch of what this thing should look like, we've got a rough idea of where these linkages should go. And we're going to start off, and these again are going to be in the vertical position. So I'm going to do, a linkage over here and a linkage over here. Okay, now we don't actually know, there's too many unknowns here. So we've got the length of these two and the pivot points at each end. So there's essentially 6 unknowns there. So putting those all together is going to be, it's a difficult task normally. So we'll be using nice use of the parametric sketch to make that possible. Okay, so I need to be able to position it along here. Now, this is a little trick I like to use, and this is one of the things that we should consider here, is that I'm actually going to draw this line in 3 segments, so it gives me 2 points in the middle for a pivot point. And you'll notice that when you sketch, if you hover over a previous entity, it will infer, in this case, parallelism. So I'm just basically drawing 3 segments. That's a parallel. Okay, you can see that there. And then just to position it and get the length right, I'm going to use the coincident constraint to make this attached to here, and then I'll attach these two to here. Okay, so we're getting something here now. So we're getting these two connected, and they have a pivot location relative to the center of the mechanism. The next thing I want to do is to, because it's symmetrical, I won't bother doing the right-hand side, but we do want to do the vertical position. So I'll do an exact similar sort of thing, and I'm going to draw it exaggerated. I don't want to draw it, well, actually, I suppose I could draw it vertical. So I'm actually going to draw it 3 segments again. Going to attach these two to here, attach that to that endpoint. So essentially, we've now got two locations of this beam split over 2. Now, hopefully this is making sense. And the trick here is to make all those 2 segments there equal. This segment and this segment equal, and this segment and this segment equal as well. Did I make a mistake there? No, I didn't. That's right. So those two there are equal. It's actually that was putting me off there. And that one equal. And then the final thing we want to do is just replicate these two here as well to be in that vertical position. So again, we're going to draw construction lines. The only reason why I'm using construction lines is just to make it easier to differentiate between what is what. So I'm going to draw, in fact, let me just do it from this base location. So it's got the same location here to here. We'll make those two equal, those two equal. So again, that's the same link, just in 2 positions, and then just attach that point to there and this point to here. Now, hopefully that is making sense. I've got too many constraints there, perhaps. Perhaps I shouldn't have done it. Sorry, that needs to. Sorry, that needs to attach to there. That's why. Okay, and I've all messed up here, haven't I? So I've got too many things going on here. Let me just do something real quick. So I've got these two equal, and these two equal as well. So that is equal with that, and that is equal with that. Okay, that's good. And then I just need to put in, I'm just going to put in this other line over here, but again, just going to exaggerate that a little bit. So 3 segments, that's going to represent the main line. I'm going to make that equal, that equal, that equal, and attach that to there, and attach that to there, and attach that to there. Now, I'm forgetting what I'm doing here. Now, attach that to there. Okay, now if I make this vertical, I've messed up here somewhere. Okay, so that's going to give me. So that is there. Okay, so that's done it there when I just snapped it down to vertical there. So that is actually giving me the position of these beams, of these linkages, I should say, in 3 positions. It's perhaps not so clear here. If I'd have drawn it over both sides, it might have been a bit more obvious. Okay, but that now gives me multiple locations and multiple solutions for these beams. And what you'll see is then, let me just create a third sketch and you'll see how it works. So over the front of this, and I do apologize for that slight error there, I'm going to draw these 3 beams in again just to give us our reference point. Make those equal, and then just to test the motion, and then we'll just draw a line over here and a line over here. Attach that to here, attach that to there. So we've got the pivot point here, and the pivot point is the horizontal here, which is probably what I was messing up before. And then just need to make sure that these 2 lines are equal and these 2 lines are equal. Okay, so so now we're looking pretty good. In fact, I don't want to make that horizontal because I need to make this slide. Now, as I begin to move this now, you'll see you actually get the motion, and that point now works in a straight line. So just to recap, I know that wasn't so clear because I should have really just sketched it over on the right-hand side, would have made it clearer, is that by positioning the linkage in multiple locations and setting each length to be equal, it gives you the capability then to work out where these linkages and the pivot points should be. Now you'll see that at the top points here, this moves slightly off, which is right, because that needs to do that in order for this linkage to work. So you see it gives this kind of motion in here. Now what is important with this kind of thing as well is that because these are all they're all variable, then really from a design standpoint, you can change this to be any position you want to be. So if I move it up to there and then edit this final sketch here, you'll see you still get the horizontal motion. So the only consideration you need to be wary of now is, what is the critical dimension that you want to drive. So again, from sketch 2, the critical dimension might be, I don't know, we want this to sit on this bottom pivot point here, and again we've now got this here, and we can still get the same very same motion. Now to build from your 3D model from that is just a matter of selecting the geometry and building other sketches around them. So for example, you could pick these 3 guys. In fact, and what I'm going to do is just going to build one more sketch just to drive the profiles, and this time it's going to be just one sketch for this, and one for this, because I actually just wanted this to be one continuous line. So this is just basically just going to drive my profiles. Then you can use the slot command, for example, to build those profiles that you want to use, and then build the 3D geometry from it. To make it easier as well at this point is to add a circle, which is going to be a hole. So just give you the pivot points. And so from that, you can then build each individual piece of 3D geometry, like you can see here. That will give you the profiles. In fact, you can see from here we have sketched it in the very same way, created 3 extruded profiles, and then you must take it into the assembly to add the revolutes and the and any other constraints in there or mates to actually make this thing move. Okay, so sorry that was a little bit disjointed. What I'll do now is actually show a similar sort of thing on the project I was working on recently, which will make it hopefully a little bit more sense, and also how we can do it uniquely in Onshape. So really, any parametric sketcher can do that, but what I've just seen there. But let's take a look at how we can do that in Onshape specifically. Okay, so I was working on this project, working on this mixing bin, and the idea here is that you have a bin which is sat on a frame, and if you have a look at the bin assembly itself, then it's basically a motor-driven. This thing spins round and mixes whatever you put up into it. But then obviously the ultimate goal of this is once you've put all your ingredients in there, it's all mixed up, and you want to be able to tip it out. Okay, which means that when you get to your main assembly, you want to be able to get this thing and want to tip that out. So if you put the pivot point on this center here, you can see that yes, you can tip that out, but perhaps it actually perhaps there's an issue with it. And the issue here being, if I turn on the hidden edges, you can see there's a beam on the frame there. So if I move this thing, then it's going to hit the frame before it actually gets into the final position. Okay, so that's no good. So what's the other option? Well, perhaps we could move this over to over to here into the center of the thing. Similar sort of thing, and that's even worse. Okay, so we need to work out a linkage which will lift the bin up first before it allows it to tip out. And this is the process that I used. Okay, so using a similar sort of thing that we did a moment ago, what you might want to do is to take this guy, want to rotate it around 90 degrees. I want it 90 degrees to actually tip it out, and then position it in the location that we want it to be the final position where it's going to be emptied. Now, this could be done in a number of ways. It could actually be measured manually, in which case, the specification might be that you want this to be a certain distance from the edge. Okay, so that's 190. So if you want that to be 200, a nice little trick I do is that if you click on the measurement, it will automatically highlight it, so you can do a Control-C to copy it, and then so that's 190. So what I'll do, I don't want to move that, not the whole thing. Okay, so I'm going to move that by 200 minus Control-V, which is the measured value. So that's going to be in the correct location. I can just verify that so it's from that edge to that point. In the Y direction, I've messed that up, haven't I? So that's 200 minus that value. Or whatever. Anyway, so you can measure that, and similar sort of thing. You might just say, let's just turn that shaded off. You might say, okay, I want that point there. The distance between there and there in the Z direction is that. So I'm going to copy that, and I'm going to move that. Say I want that to be sorry, paste. So that's going to be exactly 750 from the floor. Another way you can do that, and probably an easier way than what I've just shown you there, is clearly, you can move this guy over here, and if you have the position created in a sketch, you can reuse that sketch. So I'm going to insert a sketch that was part of the original layout, which is this one here. which actually has the location, the final location in it. So the end of this point here. So one way to make this up is to create a Fasten Mate, and we'll use the end of that curve there, and then on the end of this lip here, and I'm going to get the center location of that lip there. So that should put that in the correct location. Okay, so that's got it perfect. So that's now 200 from the frame, 750 from the floor, and if you look at it from here, and again, just rotate it slightly, you can see that it's missed that beam. Okay, so I've now set up the design problem, or the solution, I should say. Now I just need to work out the linkages that make up this design. All right, now the way we can do this in Onshape is to use the in-context editing. Now, in-context editing allows you to position members of an assembly or components from an assembly in multiple locations and display them in the Part Studio. Of course, we create all geometry in the Part Studio, so it's just a way of getting this information over there. Now, one thing we'll do here is I know that I have, and again, it all depends on how your document is set up, but you can see I've generated basically all the geometry in one Part Studio. You know, I could have done the frame in one Part Studio, the bin in another, but it just so happens I did them all together. So there's a couple of ways we can do this. If I go to edit this bin in context, that's going to do something funny because it's actually orienting it around. There's actually nothing wrong with what we see here. It's just a little bit confusing because what the ghost image that's come from the assembly is actually, you can see it's actually spun the whole thing around by 90 degrees. So that's not so clear. So what I prefer to do is find something which is fixed, in this case the frame, and select that to edit in context. Okay, so now you can see it's in the correct orientation, and the only thing that is ghosted is the second position of the bin. Okay, now because even though I edited the frame in context, it doesn't mean that I have to edit that particular part. It just means that you're editing the Part Studio that part is contained in which case we've got everything here. So I just selected the stationary part to create the geometry. Similar sort of thing. What I'll do now is I'm going to create I'm going to use a plane. I'm going to create a plane to sketch on through that face there. And the only reason I'm doing this is that if I didn't, then any sketch geometry I use to create the linkages would actually be split up by this face. And again, if you're a seasoned Onshape user, you would understand why that is. It's because of the sketch regions in Onshape, it's trying to decide for you which areas of that face should be used to extrude. But I don't want to include any areas of that face. So I'm just going to sketch on this plane here. Okay, and I'm going to do the exact same thing that we did previously. Hopefully it's a little bit clearer this time. So I want two linkages. So I'm going to provide 2 points here. That's in the start position. And the end position, you can just see ghosted out here, is the bin in the opposite direction. Okay, so a couple of things here. Let's make these two equal and these two equal. Okay, before we start. Now, what we'll do is to take this, and it's basically using this line as a measurement from the top of this frame, and I'm going to use midpoint. So that's going to specify that this point is a certain distance in the middle of this component here. Do the exact same thing on the moved bin. And what you'll see here is now it's actually created a little purple line. You might be able to make that out, which is a reference for of the context. Okay, and the last thing we'll do then is just build the linkages. Now I know from my original napkin sketch that these linkages should be crossed, so I'm going to do one there and one to there, and then one over here and one over here. Okay, so that's the two linkages in the two positions. Make those two equal. Make these two guys equal. And the only other thing I'm going to specify is that I'm going to make the linkage appear in this position here, or in the center of the frame. Now, from a design standpoint, so this linkage now can go in any position. It can be I've actually got it horizontal with this one, but really it can go in any position. And to be honest, it's kind of, you might want to do some kind, it depends on the force that's going to be required really to drive this using the hydraulic cylinder that will push one of these linkages. But really then we're going to put in a value that is known. Okay, so if we make that 210 millimeters, it does mean that these linkages just come out as bizarre numbers, 576.14 and 453.88. That's kind of inevitable. Whichever dimension you fix, at least two others are going to be a little bit obscure. Okay, that's not really a big deal. All we need to do now is just create the linkages like we saw previously. So we'll create two slots on here. And let's just make those guys a little bit bigger. And draw some circles in. So let's make those 25. And these are just going to be the pivot points. Okay, and we'll just make those all equal as well. Okay, so reasonably straightforward this time. So again, just to recap, it's about positioning the lengths of the linkages and the pivot points relative to the two positions here. Now, if you wanted this bin to do something really crazy and go perhaps lift up before it tipped over, which it does a little bit anyway, you could actually put in a third location. That can be a little bit tricky to work out exactly where the linkages should go, but it is possible to do that. If you're just happy with two separate positions, then that's fine. Okay, so that's basically my sketch. All I need to do now is extrude the profiles that I want to use. So I'm going to use this one, and this one for one part, and let's make that 20 mil. That's going to be a brand new part. And then show the sketch again and create the other part, which is going to be this one. Sorry. Create another profile. It's going to be this one, and this one. And this time I'm going to say perhaps I'm going to go up to a face, which is the back of the. Oops. That's not doing that. Let's just pick the back of the frame. There you go. So extrude up to the frame, and then the second direction is going to be, again, we'll use up to face and select the front part of this one here. Okay, so that's essentially given me two linkages that we can then use in the assembly. Now, once we've done this, you don't actually need to use this context anymore. We can get rid of it completely. However, it's a good idea to keep it if you're still during the design phase, you're still iterating the design. So if the shape of the bin should change or the final location of it should change, you can then take a context and update it, and then your linkages will update for you automatically. Okay, but for the most part, we don't actually need that anymore. Okay, last couple of changes we'll do here is just blow some holes through these other parts where these things will be positioned. So let's remove this profile, and select two more. This guy here and that guy there, and we're just going to do remove in both directions through all. Second version through all, and the two parts we're going to do it in is this part, and this mounting plate here. So that gives me then the assembly locations for this assembly. Now all we need to do is just go back to the main assembly. We've got the parts that we need. We just need to connect them all together. So first of all, let's insert the brand new parts, and I probably should have named them. It's going to be 25 and 26, I guess. Yes. Let's just rotate that back around so it's roughly in the right position. Let me just delete that because it was fastened. Okay, that's pretty good. Let's just shift that over there before. and then we just need to add some revolute and some cylindrical mates. So the revolute mates are going to be between these two parts. So let's say between this edge here and this edge here. So that's going to be a revolute mate. Then we also want to add another revolute mate between this top part and where it connects to here. Okay, and then the reason why we want to do cylindrical mates here now is obviously because these links are now offset, they are a revolute mate won't work. But a cylindrical mate will give you the rotation, but also the z-axis motion as well. So that will then give you the required movement. So we'll do a cylindrical mate. This time we'll use any circular edge off this part, that one there, and circular edge off this part. So that positions those. And then one more cylindrical mate, which is going to be circular edge off here and a circular edge off here. Okay. Okay, looks like I messed up a little bit there. What have we done there? So 2 revolute to there. It's because the frame isn't fixed. That's why. Let me just fix that. So okay, that's a revolute, and let's not worry about that now because we're looking at the linkage. Okay, that's why, because my frame's gone awry, hasn't it? This is because I didn't fix the frame originally. Okay, not to worry. Let's just place that there and fix it once more so it doesn't move. Okay, so now it means that when I move this thing, you can now see we get this kind of motion. And in fact, if I just turn on the hidden edges, we'll be able to see where this beam is now. So now when I move this, you can see that it gets kind of a lift before it rotates around. You get it into the final position and it avoids the beam. And also then you've worked out what that linkage should look like with fairly little effort, even though I messed up a few times and I do apologize about that. So we get that linkage. Then all we need to do then from that point is decide how we're going to drive this. So we would attach a cylinder between either of these parts. It doesn't really matter, probably this part down to the frame down here. That will then give you the motion to drive this forward. Add some more stops in there so it doesn't go too far, and really the kind of design is complete. Okay, so that is that is essentially how you would do those types of linkages, and it's the in-context editing which makes this possible. Now I could have done this in just a sketch, but as the geometry gets more complex, so we've got the shape of the bin and the position of these these plates and so on, because it becomes more complex, then the in-context editing makes a lot more sense. Okay, and again you can see that as that even though I actually move the assembly, you can see that the context remains fixed, and that is really a snapshot in time. So it means that you don't have to worry about this thing messing up at any particular time. Okay, all right. So that's how you create a two-position linkage. Again, using in-context editing. I apologize for the first sketch. Like I say, I kind of messed that up. But let's have a look at one or two more things which I use quite often to build more complex mechanisms. And one which is a very popular thing is creating cams. Now, of course, the idea behind a cam is that it drives a follower, and more often than, well, in fact, in every situation, the position of the follower is what is important. The shape of the cam, not so much. Obviously, it's got to fit within a certain envelope, but it's the follower which is important. Okay, now there is no built-in function to do this in Onshape to create cams. However, most of you should be aware that Onshape is built on a language or a scripting language called FeatureScript, and basically all the built-in functions that we create in Onshape, so fillets, chamfers, drafts, shells, ribs, whatever, all these were created in this language called FeatureScript. So it enables you to build your own features to drive geometry. Okay, let me just create a brand new empty part. Let's just call that cam, and then we'll see how this works. Okay, now when you are in fact, let me just do this from a different account, just real quick, and make it a lot more sense. Okay, when you want to use a custom feature, you don't have to be able to program. If somebody's already created the feature, you can reuse it. And my good friend Konstantin created these several features to do some really complex geometry in Onshape, one of them being cams, so I'm ever grateful to him. But to add a custom feature, there's two ways you can do this. You can either search through the public database, open the document, and then press the Add Custom Features button, or you can search for them. So, for example, in this particular account I'm using here, I can see I've got a number of custom features added to the toolbar, and then there's a final button there saying Add Custom Features. Now, in here you can look at some FeatureScript samples. So these are ones that have been generated by a lot of the Onshape staff. Then there is this community spotlight. These are ones that are all listed on the website at onshape.com/featurescript. Now, not all custom features are listed here. Typically, unlike the one that Konstantin wrote, it isn't here either. So what we can do here is go to the public filter and search for it. Now, I know this thing is called sketch wrapping, and what you'll find is that any feature or any part or document which has feature script in it will be in bold. Any document that doesn't have any custom features in it will be grayed out. Now you'll see, unfortunately, there is sketch wrapping feature is very popular, and a lot of people have made copies of it just so they can play around with it, play around with the code, because he's essentially open sourced it. But what you find is it might be a little bit more difficult to find the actual original feature that belonged to. Now I know it is this one here, and the only reason I know that is because I searched for the document from the documents page, which had his name next to it, and then I know that the latest version of that is version 22, which is listed here. So that can be a little bit tricky, but once you get the hang of it, it's not too bad. Now, in this particular document, there are a number of features that he's created here. One for wrapping sketches onto cylinders, splitting curves, projecting, unfolding geometry. But the one I want to use is rectilinear to polar coordinates. And just by clicking that item there, we'll add it to your toolbar. So it means that now there is this new feature in here. Okay. Now, of course, it being a custom feature, it is at the whim of the person who wrote it about how it should be used or how easy to use. Now, this is pretty straightforward. It's essentially asking for a sketch, which is going to be essentially a graph positioning the position of the follower. Then there's a couple of options here to position it elsewhere. I won't bother with those. Change the direction of the cam, and to turn what is really a number of lines and arcs into a spline, which makes more sense as well. Okay, so let's just do this first here. So we'll start off with a new sketch, and we'll just draw in the follower position. So I might want it to stay flat, then jump up a bit, go back to flat again, perhaps jump a little higher, and then go back to flat again at the end. Now, it doesn't really matter about how the length of these lines, so the distance from this point to this point doesn't really matter, because it's going to be scaled to the size of the cam. What does matter though is the height. So if you want to make sure that they're actually, we don't want to go at 25 mils, it's too much. Let's say 10 millimeters, and we can see that scaled the entire sketch, and perhaps let's say 15 here. And of course you can add dimensions on here, but this essentially from 0 to 100% at this point. So if you want to make that 100 millimeters long and then make that's 10, that's 20 to get percentage, then that's the way you would do it. So just from a simple sketch which defines the profile of the follower, you can then use this custom feature to define that. So just hitting the sketch button, okay, we'll define that cam for me. You can see it's a little bit crazy. Now, a couple of things that's happening here is that the initial radius here set to 25 millimeters is what we can see here. So it's because it's essentially in the z direction of this sketch, it's 0 here, but it's 25 plus 0. Okay, so perhaps you want to so that's going from 25 to 35. So it's a little bit crazy. But the nice thing about Onshape is if you press this final button, you can see exactly what effect your changes have on the actual cam profile. So you can see reducing that's going to make it a little bit less crazy. Similar sort of thing on here is going to, let's just leave it 5 and 5. Okay, so you're going to get this type of situation here. So that is the cam profile. What we need to do then is create perhaps one more sketch, which is going to be the follower. I'm just going to draw a circle in this case. I'm not bothered about the size, and then create some parts out of them. Now we'll do an extrude. Use that face and that face. So those the cam and the follower. And the only really other trick is with regards to making these assemble and to add them on. You can either put holes through the center of the cam, for example, to position onto a shaft, or just for the sake of argument here, we'll do a mate connector and just add it to this this point at the moment. Okay, so we want it on. I'm just going to hide that point and hide that so I can pick the origin. Okay, so there's the so I've selected the origin. That's going to be the owner part, which is the cam. The only other thing is they want the blue axis to be the axis of rotation. So we can change this on the mate connector by using the realign option, and the primary axis, which is the Z axis, we can click that. Doesn't matter which way it's going, just so long as we've got the blue axis going along there. Okay, let's create an assembly from this. So first of all, let's just insert those two parts. Okay, let's insert those part studios, and you can see that these things here are free to move. Now, what we'll do first of all is create another mate connector in the assembly, and we'll place it on here. Okay, and that's the z-axis there is in the correct location. So all we need is a revolute between that axis and that axis. Okay, and now we've got the rotary motion that we need. Okay, the other thing we want to do is position this follower, and we can do the follower with, let me just hide part 1 to make it easier. We can do the follower with the pin slot mate. So the pin slot mate is a special mate which holds the z-axis of two parts, but allows them to move along the x-axis, which is the red axis. So in this case, with this pin slot, it's important to pick the pin slot first, or the pin first, I should say, and then that's this mate connector here, and then that should give us, if I just go around to the front motion. Oh no, done it the wrong way around, but that's no big deal. Let's edit that, and of course, if you press the play button, you can see which way it's going. Let's just spin that round. Okay, that's going down. That's fine. Okay, just so long as this thing moves up and down. So that's giving the follower motion, and we'll position this here. Okay, and the final thing to do is a tangent mate. Now, the tangent mate requires a continuous set of edges or faces. So, for example, if I select this face and this face, okay, that's all very well, but what you'll see is that and as I rotate this, as soon as it gets near another edge, it's just going to stop. And the reason it's stopping there is because it's only selecting that one face. So the way around that, there's two things you could do. You could either add fillets to the cam profile. Actually, there's three ways around this. You can edit the original custom feature and do this use single path, which is basically going to turn all those lines and arcs into a spline. Okay, so now what you'll see is now the reason that failed there is because changed a new definition. Let me just do that again. And the mate connector also failed, so let's just make that part there and that face there. Now again, the reason that fails is because the definition of the sketch essentially changed from a load of lines and arcs to a spline. And then we go to the assembly, you'll see that's also missing again because the part definition disappeared. But it's not a big deal. It's just really just to show the different ways you can do this. So add the cam revolute in there. That sort of thing here. You can now add the tangent mate between this face. You can pick a face or you can pick an edge. It doesn't really matter. And that's going to sit on there. So you've now got what is essentially a fairly complex cam profile being driven from a very simple sketch. Now, in reality, what you might want to do is in that profile sketch which drives the follower, is to add some fillets between the sharp edges so you can define exactly what the shape should be. Because at the moment here, and what you'll see as well is that as this cam, once it, you might see sometimes that it actually digs into the geometry. And that is essentially because there is more than one solution, or the radius there is too small for that to work out. So again, you might want to add that capability into the sketch. And it's very simple to do. Just going back to here, change the original sketch. And what we'll do is we'll just put some fillets in here, whatever size, not really bothered, just to round off some of these edges. Okay, let's make those a bit smaller as well. Okay, so that's okay. I missed a couple there, no big deal. Okay, so that's going to rebuild now proper arcs within your profile. So now when you come to the assembly, you're going to make sure that there's no positions where that follower actually has more than one solution. So then you're going to get a lot better following on from the cam. Okay, so that's essentially what I wanted to cover today. I do apologise at the start when I made a little bit of a mess of that sketch, lack of practice. But essentially, building either a sketch layout to drive your linkages and making use of the equal constraint is the way forward. Unique to Onshape is using the in-context editing, which means that you can position complex assemblies in multiple locations to work out linkages. And then for more complex things, like cam profiles, it's not something which you'll find in the user interface, but you can add a custom feature written by the community to do that. And the nice thing is that as we've built this custom feature to build this cam, like we've seen, make any changes to the features, the sketch, and everything is going to update for you automatically. Okay, like I said, there was only ever one slide. The last thing I just want to do is ask if there's any questions. Hopefully that covered. Hopefully you understood it. Please again contact me if you need to ask any more questions, or you've got a particular scenario even that you are struggling with and you want to be able to solve. I'll be quite happy to help you out with that. So I will stay on the line for a while to answer any more questions. Please type them in if you need to. But other than that, I'd just like to wish you a good day, and thanks for attending.